The National Map is a collection of mapping products and services produced by the USGS National Geospatial Program. The products and services are accessed via the Internet through service calls and graphical user interfaces. The National Geospatial Program has released a series of how-to videos for people who are working with the National Map data and services. The videos show how to use the services and interfaces to access data and tools for viewing, analyzing, and printing geospatial data. The training materials are a mixture of video and PowerPoint-based lessons. Lessons 1 and 2 serve as an introduction to the training materials. The remaining lessons are designed as quick how-tos and may be viewed as needed in any order depending on the user. Lesson 10E1, Products and Services of the 3D Elevation Program. In this lesson, you will learn about the Lidar products available through the 3D Elevation Program, which is abbreviated 3DEP. The lesson will introduce 3DEP, discuss the Lidar data available, and where to find the data. The USGS has a long history of providing elevation data, first as contour lines on topographic maps and later as digital files in the National Elevation Dataset. The 3D Elevation Program is our newest effort to provide national elevation data. The program applies Lidar and IFSAR technology to generate a complete and consistent high-resolution nationwide elevation data baseline for all natural and man-made features in less than a decade. These data are transforming industries and creating new applications never before possible. The program leverages partnership dollars and provides high return on investment, along with cost savings generated by larger dataset acquisitions. Our goal is to acquire nationwide LiDAR coverage in 8 years with IFSAR data for Alaska. 3DEP data bring much improved data timelines, detail, and accuracy compared to earlier elevation products. The data support a very broad array of applications. Some of those are shown here, including structures and bare ground for infrastructure planning, solar energy suitability, historic volcano activity, critical mineral exploration, accurate elevation detail for floodplain management, vegetation structure for forestry applications, and lines of sight between buildings for broadband. The 3DEP program is based on the results of the National Enhanced Elevation Assessment, called NEA. NEA documented the elevation data needs of 32 federal agencies, all 50 states, and a sampling of local, tribal, private, and other users. The full report is available on the USGS National Map website. NEA asked state and federal elevation data users how they would use new high-resolution elevation data and what benefits would be anticipated. The top 10 applications and estimated benefits are shown in this table. NEA proposed several different quality levels of elevation data with varying data resolution, accuracy, and cost. QL1 represents the highest quality product, whereas QL5 was the lowest. A cost-benefit analysis was performed to determine the elevation products best meeting user needs. A number of scenarios were developed, and one that met the most needs at a reasonable cost and time frame was chosen. The preferred scenario recommended QL5 IFSAR data for Alaska, and QL2 or better LiDAR for the other 49 states and the U.S. territories. Note that the current specification now includes a higher QL0 level with a greater vertical accuracy. This illustration highlights the two major LiDAR products generated by 3DEP. The foreground image is a digital elevation model showing a bare ground surface with structures and vegetation removed. The background image shows the points collected by the LiDAR sensor that are grouped or classified to show different surface features such as buildings, vegetation, and roads. A number of data products are generated from the LiDAR and IFSAR input. This table lists the different products available through 3DEP. One of the key derived products is the Digital Elevation Model, or DEM, which is a 3D representation of the bare Earth surface. DEM surfaces are formed by a grid of square cells, each cell having one elevation value. DEM resolution varies by cell size, with smaller cells capable of showing greater terrain detail. Seamless DEMs are designed to provide uniform and complete elevation data across a large region. Project-based DEMs have higher resolution than the seamless DEMs and are delivered when individual LiDAR projects are completed. Source data refers to products other than standard DEM products. Note that the 1 meter project-based DEMs and the Lidar point cloud are considered the primary 3-DEP deliverables and are available for all current Lidar acquisitions. Now we will look at each group of elevation products in more detail. The seamless DEMs are designed to provide uniform and complete elevation data across a large region. Note that the 2 arcsecond DEM is for Alaska only. The 1 arcsecond DEM is even available across Canada and Mexico, although the non-US DEMs are not being currently updated. The highlights listed here provide basic data characteristics. Seamless DEMs are always bare earth and do not include above-ground features. Hydroflattened refers to a consistent elevation built in along the edges of water bodies and wide rivers so that water forms a smooth surface. The seamless DEMs are also distributed by large 1-degree blocks, simplifying the distribution process. This is a region that is 1 degree latitude by 1 degree longitude. The blocks range from about 4,300 square miles in southern Texas to about 3,100 square miles along the Canadian border to 1,600 square miles in northern Alaska. 1/3 arcsecond or 10 meter resolution and 1 arcsecond 30 meter resolution DEM data have been around since long before 3-DEP. These early DEMs are based on original topographic map contour lines, so their data sources are older. The 1/3 and 1 arcsecond DEMs are now being replaced by new versions, made from Lidar as it becomes available. These next images illustrate the difference in the seamless DEM resolutions. This image shows a 2 arcsecond DEM with its 60 meter resolution. This is showing a coastal region in Alaska. This is the same region now showing the 1 arcsecond seamless DEM with a 30 meter resolution. Finally, this is the same region with a 1/3 arcsecond DEM with a higher 10 meter resolution. Note that the image scale has remained the same, but greater surface feature detail is visible as the resolution improves. This graphic shows the distribution of the seamless DEM products. The 1/3 arcsecond product is seamless across the continental US plus Hawaii and the territories. The 1 arcsecond DEM also has the same extent, plus it adds Canada and Mexico. The 2 arcsecond DEM product covers Alaska. More of Alaska is being covered by the 1 arcsecond and the 1/3 arcsecond DEMs, but the state will continue to be covered by the 2 arcsecond data. The project-based DEMs are provided and made available as individual Lidar projects are completed and approved. These are typically higher resolution DEMs and are not merged together to form a seamless product. These higher resolution DEMs are used, however, as input to update the 2, 1, and 1/3 arcsecond seamless layers. 1 meter DEMs have become a standard Lidar deliverable and are now being provided rather than the 1/9 arcsecond DEM. There are 3 resolutions of project-based DEMs. The following slides show some of the differences between them. The 1/9 arcsecond DEM specifications are listed here. Until 2015, the 1/9 arcsecond DEMs were the highest resolution DEM distributed online by USGS. 1/9 arcsecond is approximately a 3 meter grid cell. The 1 meter DEM is a common deliverable in modern Lidar production. Lidar meeting USGS production specifications collect enough data to support a 1 meter DEM. Occasionally, Lidar projects may provide a higher resolution DEM, but a 1 meter DEM is always generated for distribution by USGS. The parameters listed here are common to 1 meter 3-DEP DEMs. This image shows a 1 meter bare earth digital elevation model near the eastern tip of Long Island at Montauk, New York. Areas covered by water appear smooth due to hydroflattening. The collection of elevation products for Alaska is different because the data are collected with a radar-based interferometric synthetic aperture radar, or IFSAR sensor. These products have slightly less resolution than LiDAR-based products, but are still far better than the elevation data historically available for Alaska. A major Alaska elevation product is the 5 meter resolution digital elevation model. Like other DEM products, it shows the Earth's surface without vegetation or structures. The basic product parameters are listed here. Similar to some other USGS DEM products, the data are delivered by large 1-degree blocks, which makes staging and delivering data easier. This image shows the 5-meter Alaska project-based DEM for the Mount Edgecombe area near Sitka, Alaska. Landforms are clearly visible. We have covered the standard DEM datasets. Source data are additional digital elevation products derived from the 3-dep source data. The Lidar point cloud is the original collection of X, Y, and Z points gathered by the Lidar sensor and is a required deliverable. Along with the DEMs, the point cloud is the other major deliverable for 3-dep, and it is made available for all Lidar projects. Note, however, there is no point cloud product for the IFSAR sensor for Alaska. The source DEM is an optional product that may be distributed if project requirements specify a different DEM than the standard 1-meter 3-dep product. A digital surface model, or DSM, is similar to a DEM, but it also includes above-ground features such as buildings and vegetation, where present. This product is available in Alaska only. The ortho-rectified radar intensity imagery is an IFSAR product and is only available for Alaska. We will now take a closer look at these 4 source data products. The Lidar point cloud is the primary source data collected by the Lidar sensor. All other Lidar products, such as contour lines or DEM, are derived from these points. Each point has its own X and Y coordinate for location plus a Z value for height. Point clouds are often dense collections of points with multiple points per square meter, depending on the quality level. Points are typically assigned a classification by the surface they represent, such as bare ground or water. To recap, the 2 primary 3-dep deliverable products are the digital elevation model and the Lidar point cloud. These 4 images created with 3-dep quality Lidar and IFSAR technology can further illustrate the versatility of the data. From left to right, going clockwise, we have the digital elevation model of the Red River near Fargo, North Dakota, an IFSAR digital surface model in Alaska, a Lidar point cloud image of Dulles Airport, Virginia, and a Lidar point cloud image of the transportation network in Denver, Colorado. Original product resolution, or OPR DEMs, are different from the standard 3-dep DEM products, though they come from the same source material. Lidar projects vary and sometimes require DEMs that differ from standard USGS products. This could mean a different projection, resolution, format, tile grid, or hydrography treatment, such as a hydro-enforced DEM. OPR data vary by project and may not be available for all regions with 3-dep data. The National Map Viewer can show how the OPR DEMs fit in with other DEM products. Clicking on the 1 arcsecond DEM availability, this seamless product covers the entire region including Mexico. Clicking on the 1/3 arcsecond DEM, this other seamless product covers a large extent but does not go far into Mexico. Clicking on the 1-meter DEM shows the higher resolution project-based DEM for a coastal San Diego project obtained in late 2014. Clicking on the DEM source OPR also shows data covering the San Diego project area. The footprint looks similar to the 1-meter DEM, but this is a different data set. The original DEM data differ in using a state plane coordinate system and having a 2.5-foot resolution, so these are included as an OPR dataset. The Digital Surface Model, or DSM, shows all features initially recorded by the radar sensor, such as buildings and vegetation. The DSM is only available for Alaska. Since it comes from the IFSAR sensor, it also has a 5-meter resolution, like the Alaska DEM. Some of the DSM characteristics are shown here. Here is an example of the Alaska Digital Surface Model. This shows a portion of northern Anchorage with mountains to the east of the city. A digital surface model shows surface detail initially captured by the elevation sensor, so buildings and vegetation are shown. Another source data product which is available only for Alaska is the radar intensity image. These are ortho-rectified images that have the appearance of a black and white aerial photograph. Some of the intensity image characteristics are shown here. This ortho-rectified raster intensity, or ORI image, shows a region centered on the University of Alaska in Anchorage. The gray tones are based on the intensity of the radar return. Dark areas are more indicative of smooth surfaces such as paved roads or water. Rougher surfaces scatter the radar pulse and can create brighter returns. The brightest returns are often caused by man-made objects, such as sides of buildings, that can reflect the radar pulse back at the sensor. The 3-dep metadata page listed here has details on the metadata available. Metadata is available in two varieties: textual metadata and spatial metadata. USGS.gov/3dep/standards. Textual metadata is provided with the 3-dep data download. Typically, there will be an XML file containing metadata for the source of the dataset you download. Depending on the data site you are accessing, some of the metadata may be visible when clicking on the metadata link or icon. This image shows the downloadable material on the National Map Viewer site for the DEM dataset. The arrows point to viewable metadata. The metadata is also included should you download the dataset. Spatial metadata provides details on a specific elevation product, such as a seamless DEM. This metadata is provided as a shapefile with information provided for all polygons. This image shows 1/3 arcsecond DEMs in the San Diego area. The different polygons are related to the origin of the data. Identifying a polygon provides details on the elevation data, including its source. The website has a 3-dep data dictionary with details on the codes in the attribution. Most National Map digital products are typically accessed either by viewing the data through an online mapping service or by downloading the actual data files. 3-dep elevation data can be accessed through both methods. Online map services allow you to view the data in your GIS software, such as ArcMap or Global Mapper, or on certain map viewer websites without needing to download the data files. The alternative is to download the data files and view them using GIS software. USGS also has an elevation point query service, where the seamless DEM will provide an elevation value at a given coordinate. The URL for this service is shown in the upcoming links page. The USGS has a list of map services providing data from the national map. The service list link is shown here: viewer.nationalmap.gov/services. There are several map services showing products derived from 3-dep data. Shaded relief shows a seamless view of multi-scale elevation data with shading to depict surface relief. Contour lines are derived from 3-dep suitable for 1 to 24,000 scale mapping. Elevation index shows colors that represent availability for different DEM cell resolutions. 3-dep elevation is a dynamic elevation service that will incorporate numerous DEM display options. Lesson 10E3 has further details on this service. Elevation OGC WCS is a web coverage service that supports cloud-based data analysis and modeling. NED point query service was mentioned earlier and will provide elevation value for a given coordinate. This image, for example, shows the USGS shaded relief and contour line map services turned on within ArcMap software over San Diego County. No data files were downloaded to view the data. The map services are simply turned on. Since the data are being viewed in a geographic information system, you could also bring in additional local data which can be displayed along with the 3-dep products. Lesson 5 in this instructional series provides further instructions on how to use the National Map web services in ArcMap. 3-dep has applications that allow users to view and interact with the data and understand its capabilities. First, Lidar Explorer lets users view Lidar products and see their status across the country. More importantly, Lidar Explorer provides a means to access and process the data within the cloud to avoid the need to download and process data locally. Users will be able to define their area of interest, select and filter products based on needs, create processing pipelines for transforming the data into derived products or results, and execute the processing using cloud processing capabilities. The 3-dep Demonstration Elevation Viewer also displays USGS DEM data from 3-dep. The goal of this viewer, however, is to highlight the capabilities of the new 3-dep Elevation Dynamic Map service. Users can zoom to an area of interest, change the map background, view different elevation products such as hillshades, a hillshade color-coded by elevation, aspect maps, contour lines, and can employ a slide tool to switch between elevations and background data. The 3DEP Elevation Dynamic Map service has its own video available as Lesson 10E3. Sometimes it's preferable to download the data files. This is especially true, for example, if you need to manipulate or analyze the data content with other local data. 3DEP data can be downloaded from a number of source sites. This list provides the site names and links. The first site listed, the National Map Download Client, is the primary repository for digital USGS mapping data. Lesson 4 in this instructional series provides further details on using the download client. In this lesson, you learned about elevation products and map services offered through the 3D Elevation Program. Current information on the 3DEP program can also be found on the 3DEP homepage shown here, usgs.gov/3DEP.